So welcome to the new video. In this video, we're gonna learn about the importance of term enthalpy in the context of rockets. So what is enthalpy? What is enthalpy? Enthalpy is related to the energy of a gas, or enthalpy can be of liquid also. But enthalpy is a term which is related to energy, thermal energy of gas per unit mass. How much energy it carries? That is what enthalpy is. And that energy is proportional to temperature and pressure of the gas. That's why the formula of enthalpy is CPT. The CP is like, see, if you want to measure energy or enthalpy now, you need to have one thing constant. Either temperature will be constant or pressure will be constant, or how the things will work, right? So we are measuring enthalpy at a constant pressure. That's why the formula has CP, the specific heat capacity of a gas at a constant pressure. You know. So in rockets, gas expands, as you know, I have talked in the previous videos. Gas expands, it increases the velocity, and all that happens. That's why we need to learn about the energy of gas, or in scientific terms, enthalpy of the gas. Let's go. Hmm. Kinetic energy of a gas is very obvious. It will be proportional to v square. So kinetic energy is proportional to v square. So term v square by 2j, j is just mechanical equivalent of which is related to something heat kind of thing. So the whole point of this slide is kinetic energy of gas increases as the gas velocity increases. This is obvious. As the gas expands, so what happens now? Here, here there are fuel and oxidizer. Here they mixing. And that mixing raises the energy of the gas. Gas energy, boom, increases. So what happens? The gas expands, and as it expands, the velocity of gas increases. Now, I'll give you a very better example. Have you seen a pressure cooker? Pressure cooker, the one in which you cook food. We cook food in pressure cooker in India. Okay, I'll show you this. This is what I'm talking about. So what happens when you like lift this thing? Now, this is called CT, a large leader. The gas comes out at a very high speed. When you suddenly during the process of cooking and you lift this, and the gas will come out at a very high rate, at very high velocity. Okay, so that's what happening here. So inside this gas is at a what? Gas temperature is increasing. The temperature of gas is increasing because heat is provided. So this burning or whatever the gas. Okay. So the heat is increasing. So the temperature of gas is increasing. So like, but the pressure of gas is like also increasing. But the concept which I am trying to convey here, now, see, when you confine the gas in a small area and heat it, like what's happening here. We are confining the gas in this pressure cooker, and we are heating. So what happens when you lift the nozzle? It will shoot at a very high velocity. So at that point, what happened? Energy is conserved. So what is happening? The thermal energy of gas during the process of heating, which it acquires, converted into kinetic energy of gas. Okay, but the conservation of energy tells now the energy of gas inside should be equal to the gas exiting at a very high speed. So what happens at the start of nozzle near the combustion chamber, the gas has very high pressure, but the velocity is low, and it is this area. Pressure is very high because it is heating up. It is getting heated up due to the fuel. The pressure here is very low pressure. But what is high here? Temperature is high. Sorry, pressure is also high. Velocity is low because you are not allowing gas to move. Enthalpy is very high, velocity is low, kinetic energy is small. As the gas expands to the nozzle, particularly through the throat and exit of the nozzle, gas expand, and velocity increases. And if you put your mouth just above this, your mouth will blast. Okay, so don't do that. So, to total energy stay constant throughout the process. The total energy here, the gas exiting here will be constant. But just what happens? The thermal energy here gets converted into kinetic energy. I hope you get the point. It's all about energy of the gas. How the energy of gas converts thermal energy to the what? Kinetic energy. In the rocket engine, the combustion chamber generates hot, high pressure gas. The nozzle is designed to convert this thermal energy to kinetic energy, as I told you in the previous slides. Okay, so gas exits at a very high velocity, and because we are releasing the gas, which is stored at a very high pressure and temperature, so it produces a thrust, and the formula of thrust is this. This is the formula. Okay, yeah. Key idea of this video is thermal energy of the gas, which is here. Fuel is fuel is burning the gas. Like the gas is getting heated up due to the mixture of fuel mixed in the gas heats up because fuel burns, the temperature of gas rises due to the burning of fuel, and we are confining the gas. We are not alive. We are not allowing the gas to move at high velocity in the combustion chamber. So when gas passes through the nozzle, it expands on all directions, and very high speed. So the main point: thermal energy, enthalpy into the kinetic energy, and that produces a very high velocity exhaust gas, and that pushes the rocket forward. Goodbye. Meet you in the next video.